Hey, welcome back, y'all. So today we're defining the two different architectural standards when it comes to database modeling. We have Snowflake and Star Schema. Now, we're not going to sit here and say which one's better versus the other, but I will give you the facts, the pros and cons on why you can choose one versus the other. All right, so first we're going to start out with the Star Schema. So in industry, this is classified as a localized reporting solution. Why? Because if you look at the diagram, you see a central fact table, right? Connecting directly to the dimension tables. This critical architecture design is denormalization. So we intentionally repeat data such as writing the category name directly into the product table to eliminate the need for complex joins. That means that data is repeated in more than one location. So essentially, within the nucleus of this, you have your fact table. That's going to be your transactions, your by name listing of people, and then your dimensions are going to be those same things as well, along with company ID, branch ID, things like that. But it's redundant, right? Because now you have the data point in two different locations. So it's great for a local solution, but does not mean it's the best. And it's structured for one specific purpose, which is retrieval speed. So next up, we have Snowflake Schema. So in contrast, right, this is a standard for relational database design. So the architecture here is normalized. So we don't repeat data here. So if a product belongs to a category, we don't write category name in the product table. Instead, we store a category ID, which links to a separate distinct category table, meaning you have your nucleus once again of your transactions, your people, and then associated to that is going to be an ID, but then you have that ID as a foreign key tied to the primary key somewhere else in a table that does not have your by name and your transaction, just has that ID connection point between the two tables. So this structure prioritizes storage efficiency and data integrity over retrieval speed. And it ensures that each data point only exists really within one place. So what's the trade-off though, right? So this brings us to a fundamental engineering trade-off, which is the read optimization versus the write optimization. So on the left, you have the Star Schema, which is optimized for reads, where when the user opens the dashboard, the query engine has to traverse to only one relationship to find an answer. So it's fat and it's simple, right? So you have all your data kind of consolidated and heavy in one location. So on the right, the Snowflake Schema is optimized for writes, meaning when a database administrator needs to update a record, they update it in a specific table, and that change propagates everywhere. So it's lean and it's complex. So the choice of schema depends entirely on whether the system is ingesting data or presenting data. So let's look at the characteristics though, right? So speed, it allows engines to perform simple aggregation without complex logic. Usability, it removes the need for end users to understand relationship chains. Now, I'm not a huge fan of that, right? So if you're looking at things like Power BI or Tableau, you're not going to go in and need to understand all the data lineage. But for me, as a developer, I kind of want to understand that stuff, right? Even if you're just a data analyst and doing front-end stuff, you probably want to know to some degree where that data is coming from. Is it factual? Is it authentic? What was done with it? What was transformed with it in the background before you received it, right? That gold layer of data. And the reason I say that is because you don't want to just be in receive mode, right? Because being in receive mode doesn't necessarily mean that you're propagating the best data. So how did it come to be? And why did it come to be in that manner is the question I would ask. All right, so Snowflake Schema, this functions as a storage layer. So for integrity, it enforces strict referential integrity, so you cannot delete a category if products are still assigned to it. So scalability is also the standard for like SQL Server and Oracle because it minimizes the storage footprint. And it's also technically a superior method for keeping and fetching data as well. But let's just quickly do a side-by-side comparison, right? So if you focus on the last row, storage efficiency, Snowflake wins. But if you focus on speed, Star wins. So I guess at the end of the day, it really matters on what you want, right? How do you want the data to be connected? How large is your data set? How much are you working with? and how much is optimized and how much you need to optimize and where are you doing the optimization to, are all the questions that you would have to ask. So let's look at it from a coding lens, right? So on the left side, you see a table definition for Star Schema. This is flat, so you have all your data kind of in one location, right? On the Snowflake Schema, you have two separate tables, and you join the data together so that you can see where it comes from and where the originating fact and dimension tables reside. Now, the downside here is that the join is a specific technical cost, and it does slow down reporting tools. Now, for the Power BI perspective, it runs on Vertipack engine. So it's built to compress repeated data, therefore the storage penalty of the Star Schema is effectively nullified by the engine's compression. However, it's not optimized for hopping across multiple tables. So we force Power BI to use a Snowflake Schema. We force the DAX formula engine to perform expensive lookups for every single calculation. So what does that mean though? That means that all the transformations you're doing on the back end and then in data view and then on the front end right within DAX, is going to create more difficulty when it comes to optimization because now you're doing a calculation and retrieval for every single thing that you're trying to run on the front end. Now, just to summarize, we utilize this Snowflake Schema for a central database layer, and then we use a Star Schema for a localized reporting layer.